A random walk is the process by which randomly moving objects wander away from where they started. In probability theory, a random walk is a stochastic procedure used to estimate where a point undergoing random displacements is likely to be found, assuming each step has the same chance of moving a fixed distance in any direction. Each new position depends only on the point's current location and not on how it arrived there. Many economists suggest that over time, price movements are practically random walks. This is because for most people, the sudden moves in the stock market are a mystery and they appear to have little to do with logic. We sometimes observe bear markets in times of financial success and strong bull markets in the depths of recession. It seems like a place for gamblers or for those people that work in the city or on Wall Street who must surely know exactly what's going on, but this is not true at all. Random walk theory suggests that changes in asset prices are completely random. This means that stock prices move unpredictably so that past prices cannot be used to forecast future price. The idea is that stock price reflects all available information and adjusts quickly to new information, making it impossible for the trader to actually take advantage of it. This is also the main point of the efficiency market hypothesis. The main criticism of random walk theory is that it oversimplifies the complexity of financial markets, ignoring the impact of market participants' behavior and actions on prices and outcomes. Prices can also be influenced by non random factors, such as changes in interest rates or government regulations, or less ethical practices like insider trading and market manipulation. So, those who describe market activity as random are simply using the term loosely, and what they really mean is that movements are chaotic. Chaos is not quite the same thing as randomness. In a chaotic system, there may be hundreds or even thousands of variables, each having a bearing on the other. Chaotic systems may appear unpredictable, but as technology advances, we will start to find order where before we saw randomness. Without any doubt, it is possible to predict the movements of the financial markets, and as technology advances, we will become better at it. So, what is the difference between a chaotic system and a random system? In a random system, every value is stochastically independent from the others. This means if one knew all the available information, they wouldn't have an advantage. In a chaotic system, there is some form of law that dictates each new value. If you have a large amount of information, it is possible to predict in the short term. However, within a long time horizon, that sensitivity prevents you from having reliable long term forecasts. Imagine two identical marbles that start along a double pendulum. The trajectory is governed by the law of physics, but after a few oscillations, it is impossible to know exactly where each will end. Let's look at another example. In the random case, each new number is independent of the previous one, like rolling a fair die. There is no memory and no reason the next value should resemble the last. In a chaotic system, there is indeed a well defined rule generating each new value, yet, even a microscopic difference in the initial condition causes the two trajectories to diverge extremely rapidly, step by step. It is precisely this extreme sensitivity that makes chaos unpredictable in the long run, even though it remains a deterministic phenomenon. In the end, we can confirm that those who say price movements are unpredictable are basically wrong. There is an entire field of science, which you will surely know, called quantitative finance, that uses advanced mathematical and statistical models to predict market movements and answer complex financial questions. So, if the market were really random walks, what is the quant work for?